Robots are pretty cool. Basically, they do a lot of work for us so we can be more lazy, which is okay, because I'm lazy, to some extent. So today I've decided to try use robotics on something that will hopefully help a lot more people, and by people I mean doctors and therapists and patients. This is Rehab-Bot. So this is a weird looking robot, but it might just be the future of physical rehabilitation. I've been looking at people who lost their ability to walk due to accidents or diseases, and the process of regaining that ability to walk is really tiresome and, I mean, ridiculously labor intensive. As a person, I'm really grateful of having functional legs and hands, but sometimes life sucks when you're confined by fragile flesh and bone. So the ability to walk is one of the most amazing things us humans can seamlessly do, but often we just take it for granted. What if we can make a device that can help patients through that labor-intensive process of rehabilitation using robots? So, people who recovered from stroke or spinal cord injury, or having just gone through knee replacement surgery, usually these people suffer from lower limb impairments, or basically leg paralysis. As a result, these people just can't use their legs anymore and they lose the ability to walk. In order to get them to use their legs again so that they can walk is basically trying to use their legs again. So one of the early stages, if you're bedridden, usually you just have to try to regain that muscle strength using what's called a progressive resistance training. So basically this is like having your legs going through some resistance, like using one of those leg presses machines, so that the muscle strength increases gradually until the point where you can actually use them to practice walking again. So there's also been a growing body of knowledge where there are people who develop home-based rehabilitation devices. So basically, for the case of people who were bedridden and having lower limb impairments, it's difficult for having them going to hospitals in order to get therapy. So why not bring therapy to their homes to make things much easier and flexible? So my plan here is to make a device that can bring muscle recovery for patients with lower limb impairments to easily conduct rehabilitation from home. So how do I make this portable device that can provide muscle training for patients? Have you ever used those virtual reality goggles and feel convinced that you're about to fall off a cliff? The principle is quite the same. That's where virtual reality comes in. So my strategy here is to make a robot that can somehow generate certain levels of resistance for a patient to interact with using their muscle strength. The resistance level should also be adjustable so that the patient can train based on their available muscle strength. But all that must be in one device. This can probably make rehabilitation for them easier instead of making a system like those leg presses, which are spacious and bulky. To understand how I can artificially generate resistance, here's a low budget slash kick-ass animation to break it down. Dun 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 dun. Imagine a user's leg placed on a slider. Let's say that the slider is mounted with a spring and damper to a wall. The user then applies force to the slider, and depending on the amount of applied force, the position of the slider changes, which depends on the stiffness of the spring and the amount of damping that occurs. Now, because the relationship between the position and applied force is deterministic, given a certain spring and linear damping value, we can replace the actual spring and damper with an electric motor, a transmission, and a computer that directly controls the position of a slider. All we need now is a way to record the applied force. This is done by putting a force sensor on the slider. Finally, we ask the computer to render a certain spring stiffness and damping value, and we can basically replicate the slider's behavior to mimic that of a spring damper system. The beauty is, we can render many spring stiffness and damping value, so long as it is within the electric motor's capacity. The integration is one of the parts that I had fun filming and editing for this part of the video, so I give you a system integration montage in 90 seconds or less. I also took the time to make a decent user interface peripheral. I usually do sketches before making a CAD model, just so that I know what I'll be modeling.
So I'm going to show you two of its main features. The first feature is called the passive training mode, and the second one is called the active training mode.
Passive training mode is essentially the rehabilitation routine where you use an external influence, such as a therapist's hand or a robot, to move your lower limb joints without you moving them yourself, thus, the word passive. This exercise is to prevent joint stiffness due to prolonged immobility, such as after undergoing knee replacement surgery. You're not allowed to move the joints yourself because you may injure your leg further, so you need something else to move the joints for you so you don't strain your leg. You can see that all it does is move the joints back and forth like what you see right now. Active training mode, in the other hand, is what we call as the resistance training mode. As mentioned in the previous kick-ass animation by yours truly, the position of the slider is controlled by a motor to behave as if the user is interacting with a mass spring damper system as the resistance. The slider is positioned at a certain origin at flexion point. That is when the knee is bended, and the user may attempt to displace the slider with their own muscle strength. Using a force sensor, the system tells where the slider should go based on how a mass spring damper should behave. You can see in the footage that the user is interacting with the slider system, and the slider position is generated based on how hard the user's feet is pushing the slider. Another thing I want to show you is how Rehab-Bot can generate different resistance level. So here's the system with a certain resistance level. You can see that I can displace the slider pretty far away from the origin point. When I increase the resistance level, which is increasing the virtual spring stiffness, it's actually really hard for me to push the slider as far as when I did before. I even struggle a little bit there. You may be wondering why the mechanical design of the robot looks like this. For the mechanical designer was trying to adopt the design of a continuous passive motion, also known as a CPM device, which is actually an existing rehabilitation tool sold by many companies and is also being optimized by many universities. This is an example of an existing device that I took a look myself in a hospital. Basically, a CPM device only does passive training mode. The reason I chose to adapt that design is because it's actually a really compact device, which makes it perfect to be a home based device. If somehow we can add that resistance training feature to the device, like how I did, I think it would be a really great rehabilitation tool. One of the issues that I have is that my design didn't seem to be as compact as I planned. I think I need more time to carefully make the device as light as it needs to be. The structure doesn't really have to be made from metal, it can be made from plastic, nylon, or any other solid and light material. I was thinking that maybe a device like an SLS 3D printer could be used to make the mechanical structure that holds the user's leg, but sadly I don't have those 3D printers here in the lab.
So I was planning to actually use a brushless DC motor instead because they actually have a higher power to weight ratio compared to stepper motors, and they're also much less noisier. But the problem is I kind of took a while on trying to make a position controller, and I ended up and it kind of took a lot of time, and I kind of failed in that part. I bought a field-oriented control driver right here, and I kind of accidentally burned it because maybe there was something wrong with my code. So because I was running out of time, I just opted with using a stepper motor instead. I really wanted to master how to control these things from using a field-oriented control driver and Also, it's because these motors are actually high performance, but maybe next time. So that's everything I'd like to share. I hope you enjoyed the video. I kind of glossed over a lot of details because I don't want to make it a long, boring video. And I'll see you next time.
That's a bit awkward for an outro.